Alright, so we are on day 4 looking at quadratics, finding relationships between the different forms of the equations and its graph and some specific things about the we're going to start in number 20, and in 20 we're given the standard form and we need to find all the other pieces. We have 3 days prior experience here, so what do you want to find first? What can you find? Y-intercept. That's the easiest thing to find from standard form. You plug in 0 for x, and what do you get for y? 1, because everything with x zeroes out. So 0, 1 is my y-intercept. Okay, what next? Factored form. Okay, so what is a factor to? Or you were thinking two numbers, right, that multiply to 1 and add to 3. What are they? So, thank you. There are actual numbers out there that will work, but they're not rational numbers. And so they're not numbers that we can come up with anything that we know. And so we're not going to be able to factor over the rational numbers. Later on I can come back when we get to the end of this problem, we can look at what those numbers would be. Right? There's nothing in terms of the integers or fractions that we know that would make this work. So it is not factorable. And so there is no factored form for this problem. So what do we do now? Because we relied heavily on factored form, because factored form gave us our zeros, and then from there we got our line of symmetry, from there we got our vertex. Everything relied on us having that piece. So we're kind of like we can't go anywhere right now. So the big part of today's lesson is for me to teach you how to skip factored form and how to go from standard straight to vertex. Okay, and it's going to be a method that I'm going to teach you called completing the square, and it's going to be something that you're going to need for Math 3 a lot. And so I'm going to ask that you take out a separate sheet of paper. We're going to take some notes on that, and we'll come back to this. But we need to have a little bit of practice on completing the square. So we're going to call this how to move from standard form to vertex form. So if it factors, factoring is the easier route, but not everything's going to factor. In fact, you know, in the real world, most things don't factor. And so what I'm teaching you here is going to be a more powerful form. This form, what I'm teaching you, works on all the factorable things, but it also works on anything that doesn't factor. The key here is for us to think about perfect squares. So with numbers, 9's a perfect square because it's equal to 3 times 3. 16's a perfect square because it's 4 times 4. So a perfect square is something that's factorable to two of the same factors, right? But I don't want us to think about perfect squares of numbers. I want us to think about perfect squares of equations. So, for example, if I have x plus 3 squared, and you were to multiply that out, there's some work in between. You go x plus 3 times x plus 3, there'd be distributing, and then simplifying. What would the final answer be, though? Some of you are getting good at doing this in your head. After all that work, what would the final answer be? Yeah. Okay. And let's do another one. We're just going to look for some patterns here. Let's say x minus 5 squared. You multiplied that out. Went through all the work. What would the final answer be? And let's do one more. Let's say x plus 10 squared. X squared plus what? 20x plus 100. Okay. What if I do this? Well, let's start from the right side now. Let's say we have x squared plus 16x. And I have freedom to add whatever I want here. And I need to choose the correct number to add so that if I were to factor this, it would factor to a perfect square. What number would I want to add? What would I want to add? 64. What are you doing in your brain to get that 64? Okay, you're starting with the 16, and you're thinking back this way. Well, if that's 16, then over here I should have an x plus 8, because I want that 8 to be half the 16. And then you're taking that 8 and you're squaring it, 8 times 8 to get 64, right? Is that kind of the natural process of thinking? Okay. And there's this relationship between those three numbers, and that's the relationship we're going to be looking at. Let's do one more, though. Say we had x squared minus 22x. And I want to know what to put after the 22x so that if I were to factor it, it would be a perfect square. So we're thinking, well, what would this be first? This is going to be x minus 11. We're getting 11 because that's half of 22. And then we're going this way to get 121. Okay, good. What happens if I do this? X squared plus 5x, and it's not an even number now, right? Because we may run into this kind of thing if we have an odd number there. Follow the same pattern. Like we first would think, okay, what would go in here? X plus what? You cut it in half. So you take that 5, cut it in half, and you get 5 over 2. And then that tells you what you're going to add over here. You take the 5 over 2 and you square it to get what? 25 over 4. So it works with fractions too. In general, this is only going to work when a is 1. So we're going to have this form, like x squared plus bx is what we'll start with. Okay? And we're going to want to create a perfect square. And so over here is going to be x plus what? Half of b, I'm going to put b over 2. And then over here, we're going to put what? B squared over 4. So b times b and 2 times 2. And so this is the process of completing the square. Everything we've been doing here is what we call, mathematically, we call that completing the square. And completing the square is used for lots of things, but one thing that's used for is to go from standard form to vertex. So we're going to put a pause on this. We'll come back to this when we need to. We're not done with our notes here, but we have enough now to go and attack that problem we've been working on. So let's go back to number 20. Which we found didn't factor. So we need this new idea of completing the square. So when you have this equation, the part that you're going to focus on for completing the square is the parts with the x. So the x squared and the 3x. That plus 1 is additional information. We're going to keep it there, but don't worry about it. We're going to focus in on that x squared plus 3x. And so for a little bit of scratch work here, eventually you're going to be good at this, do this in your mind. But right now, let's say, so we got the x squared plus 3x. We got to think about what we want to add to create a perfect square. And so we think, well, the 3's here, that's our b. We're going to cut that in half to get this part. We get x plus 3 over 2, and it's going to be squared. And so then that helps us think about, well, what should I add here? What should we add? So 3 times 3 is 9, 2 times 2 is 4, 9 over 4. Good. And so that is not our problem, but that's going to be very helpful to us as we work through our problem. So back to our equation. What I'm going to do with the equation here, I'm going to write y equals x squared plus 3x, and I want that 9 over 4. Because if I put that 9 over 4 there now, then I can factor it to a perfect square. So I'm going to put plus 9 over 4. But then I put something there that shouldn't be there, right? So it's like your equal sign's like your balance, and I've just added a little extra weight to that side. And so I'm going to take that weight back off. So I added 9 over 4, and then I'm going to subtract it, take it back off, and then I got the plus 1. And I'm going to talk about why all this is here in a second. So hold your questions. So first thing is I want to point out that all 3 of the original are still there. We got our x squared, our 3x, and our plus 1. Okay, so all 3 of the original are still there. I just added in a 9 over 4, and the reason I put that there is for the next step. I'm going to want to create a perfect square because the vertex form has perfect squares. And then I had to put that minus 9 over 4 because 9 over 4 minus 9 over 4 is really 0. And so now this equation is really equivalent to the original equation. So I have to keep that in mind. I always have to keep my equation equivalent to the original, but I'm changing the way it looks. I'm being a little creative here to get it into the form I want. Okay, so then my next step is to factor that, the first 3 terms. We already know what it's going to be because that was in our scratch work. It's going to become x plus 3 over 2 squared. And then the last piece, I need to find out what negative 9 over 4 plus 1 is. Well, 1 is 1 over 1. I need to multiply top and bottom by 4 to get a common denominator. So we add negative 9 plus 4, which is negative 5 over 4. And that is vertex form. Okay. We did it. Okay. That's the first time. This may, first time through, is going to seem a little overwhelming, and it should the first time. Second time will get better. Third time will get better. Okay. So hang in there. So that is the method we use to go from standard vertex. We still need to find our zeros, but let's find out what's easiest. Let's get our vertex. So vertex form gives us vertex. What's that going to be? Negative 3 over 2 and negative 5 over 4. All right. What's our line of symmetry going to be? Negative 3 over 2, because the line of symmetry is the middle of our graph and the vertex is in the middle and they share the same x value. Okay. I'm going to pause for a second and just point out something. On the bottom here, we have some notes. So written out, kind of what we've been doing on our notes. These are the steps that you would follow to complete the square. there's a step in here that we haven't done yet because we haven't gotten to the complicated thing. We're second step, but we did the first step, we did the third step, fourth step, fifth step. Okay. Now the second step we'll look at in a second on another problem. Okay. But just want to point out that those steps are there. So how do we find zeros in general? And I wrote this on your very first page of your notes if you need to look back there. What does it say? To find y-intercepts, you got to do what? For x-intercepts, sorry. X-intercepts, you plug in 0 for y, right? And it doesn't matter what form you're working with. It's easiest to do it with factored form. That's why we use factored form. But you could plug in 0 for standard form and find them. That's the hardest one to do. We don't have a method yet for that. We will eventually develop that. Or plug in 0 for vertex form. That's the second easiest one to use, and that's what we're going to do now. So let's do that. So I'm going to have the x plus 3 over 2 squared minus 5 over 4. I'm going to plug in 0 for y, but I'm going to put y on the right-hand side. It's a little easier to work with 0 on the right-hand side. So when you do this, we're going to, the thing that's helpful is this squared part. We do not want to get rid of the squared part. You want to solve for the squared part, and then we'll take the square root. So solving by square root will be our method. So I'm going to move that negative 5 over 4 to the right-hand side by adding 5 over 4. We get x plus 3 over 2 squared is equal to positive 5 over 4. We pause here and remind you of something that you probably have seen in other classes. We haven't really done it in this class, but you've probably seen it in other classes. If I have an x squared equals 9 and ask you to solve for x by taking the square root, what's your answer going to be? What is it? Ian? Okay, there's absolute value. I'm going to skip that part, but yes, you're right. It is there. But what's the final answer going to be? What'd you say, Chris? Plus or minus 3. So a lot of people, common mistake is to say answer is 3, which is half the answer because 3 squared is 9, but so is negative 3. If you square a negative, you're also going to get a positive answer. And so bottom line is when you take the square root of both sides, don't forget to put a plus or minus sign because you could have that positive or that negative value. They both work. You get two answers. Okay, so that's going to come into play here because we're going to take our square root of both sides. When I take the square root of the side with the variable, I'm just going to write the x plus 3 over 2. When I take the square root of the side without the variable, that's where I'm going to put the plus or minus. And it's the square root of the whole thing, which is the same as taking the square root of the top divided by the square root of the bottom. And so I've taken the square root of both sides of that equation. Last step, I want to get x by itself, so I'm going to subtract 3 over 2, and I get x is equal to negative 3 over 2 plus or minus square root of 5 over, I know the square root of 4 is 2, so I'm going to change that to a 2. And I can write this as one big fraction because I have same denominator, so negative 3 plus or minus square root of 5 in the numerator all over 2. Now when you have that plus or minus, that's telling you that that's not one number, that's two numbers. And if I split that up, one of the numbers is going to be negative 3 plus square root of 5 over 2. And the other number is going to be negative 3 minus square root of 5 over 2. And so now these are our zeros, or our x-intercepts. Not quite sure where they are. in terms of graphing them, but we found them. Okay, and our calculator would, decimal value is going to be what's going to be helpful. And you are welcome to use a calculator on any quiz or tests we do in this unit, as long as it's not a graphing calculator. So one of the zeros is going to be -3 minus root 5 over 2, 0. And the other one's going to be -3 minus root 5 over 2, 0. What's that? Oh, I meant plus. Thank you. So back to our factoring question. What two numbers multiply to 1 and add to 3? And I kind of found them. Okay. I'm not going to do that, but all right. And actually, these you'd have to take the opposite of this, the way it works for factoring, but the numbers would look something like this. All right. So before we leave these, let's get their approximate values, because that's going to be helping us with the graphing. So with our calculator, if you have one, you can try that out. You get something like this, it's good to just get a decimal approximation. 1 decimal place is good enough for graphing. So I'm putting approximations down, but this is going to be very helpful to us when we try to figure out where to put it for our graph. So I got -2.60 and -0.40. I'm just rounding to the nearest tenth. And okay, so this is what you should be getting on your calculator. If you're trying to type the whole thing into your calculator in one swoop, you're going to want to put the numerator in parentheses. Or you can find the numerator, you can type in like -3 minus square root of 5, hit enter, get a decimal, and then divide that decimal by 2. But these are what you should be getting. All right, so time to graph. Also, our vertex, it may be helpful to realize that, okay, -3 over 2 is -1.5, exactly, and -5/4 is -1.25. It's always easier to think of graphing in terms of decimals and in fractions. That's the only time I like decimals. So let's sketch this. Starting with the vertex at -1.5, -1.25, roughly here. Okay. And then my zeros, -2.6 and -0.4. And then our y-intercept was 0, 1, I think. Yep. And we want one more point. Anybody give me another point that would work? -3, comma. So I'm asked, the best thing to do is just reflect 0, 1 across that axis, and you get -3, 0, comma 1, -3, 1. And there is our parabola. So domain is going to be all real numbers. Justin, what's the range going to be? Good job. Okay. Increasing and decreasing. Where, CJ? Where's it increasing? On the right. So what would I write down here? Good. Decreasing would be less than. And we got our 5 points. I'm just going to write them in here. -3, 1. -3 minus √5 over 2, 0. -3 halves, -5 fourths. -3 plus √5 over 2, 0. And 0, 1. We did it. Monster problem here. Okay. But we saw a couple new things here, and I'm going to just remind you of the new things. We found out how to go from standard form to vertex form using this new method we call completing the square. Another new thing we did is we solved for our x-intercepts using vertex form. And so we used a method called solving by taking the square root. And that helped us find those. So when factoring fails you, this is a route to take. Okay. Well, let's try this again. So 19 will be like that. I'm going to save that one for you to do on the homework. Let's do 21. No, we will. Not ready for 21 yet. Let's go to the next page. Let's do 23. All right, what can you do on 23? Y-intercept. All right. It's always nice to do that. I feel like you got something. What's the y-intercept going to be? 0, 4. Okay. Then what? Try to factor. Does it factor? Don't try? Okay. We won't try. It does factor, by the way. What two numbers multiply 4 add to -5? -4, -1. But we're not, so that would be the easy route. Factor, it works out smoothly. This would be like problem number 1, okay? But because we're practicing this new stuff, I'm going to do it the new way on this. Okay, just because you need practice, not because this problem needs it. This problem does not need it. We're using a kind of a bazooka to kill an ant on this one, right? Okay, that's what we're doing. It'll work, but it's a little more powerful than we need. But you guys need to practice. You need practice using this new weapon here, right? So let's try going from standard form directly to vertex form. So what we said to do is focus in on the parts with the x. And again, I'm going to just think, how would I turn that? What would I need to make that a perfect square? Little scratch work here. Maybe I'll put it over here. If I take the x squared minus the 5x, what would I want to add to create that perfect square? And what would that perfect square be? And it's easiest to answer, what would that perfect square be first? It's going to be x what? Minus 5 over 2. So you're cutting that b in half. It was a negative 5, now it's a negative 5 over 2. And then you're going to square that, and it's always going to be positive when you square it. Negative 5 over 2 times negative 5 over 2 gives you what? 25 over 4. And so once you get that number, that tells you what your next step's going to be. That's what we need to add and subtract. So we're going to write y equals x squared minus 5x. I'm going to squeeze in that 25 over 4 because that's where I want it. But because I put that there, that didn't belong there, I need to subtract the 25 over 4 and then plus 4. So again, you're making sure that the three originals are still there, and they are. And then you're adding in what you need to complete that square, but then you got to balance that equation to make sure it's still equal to the original. Once you have that, the first three terms factor to that perfect square, and it's going to be x minus 5 over 2 squared. That's what we saw that it was equal to in our scratch work. And then we need to add the last two terms. Right now it's a 4 over 1. I need to get a common denominator. What are we going to get when we add those? Okay, negative 25 over 4 plus 16 over 4 is negative 9 over 4. And now we have our form. We can write it over here in vertex form. What's our vertex going to be? Positive 5 over 2, negative 9 over 4. Axis or line of symmetry equals 5 over 2. Okay. So I want us to get our zeros. Again, this easy way is to factor it and get our zeros directly that way. But let's practice getting zeros from vertex form. So I want you to start by taking the x minus 5 over 2 squared minus 9 over 4. Set that equal to 0 and solve. And this one should be some nice answers. Because it factors, you're going to get nice zeros. And you'll get two integer values if you do it right. So try solving it. See if you can get those two integer values. So as you solve this, you're going to add 9 over 4 to both sides. You're going to take the square root of both sides. Don't forget the plus or minus. And then you're going to add 5 over 2. And I split them up into two possible answers, or the two answers. One is 5 over 2 plus 3 over 2. And the other one's 5 over 2 minus 3 over 2. And on the first one, you get 8 over 2, which is 4. The second one, we get 2 over 2, which is 1. And so we have a 0 at 4, 0, and we have a 0 at 1, 0. So what's our factored form going to be? Let's use our zeros to write, don't factor it. Use your zeros to write factored form. It would be y equals, what's a? 1. And what are our two factors? If you have a 4 or a 0, x minus 4 is going to be a factor. And if 1's a 0, then x minus 1 is going to be a factor. And if you go and try to factor it, you'll get exactly that. So we definitely went the hard way to that factoring, but it works. And understanding those connections, the more you understand those connections, the better it is for you. All right, we got everything we need to graph this. 5 over 2, just to remember, that's 2.5. Negative 9 over 4 is going to be negative 2.25. So starting with my vertex at 2.5, negative 2.25 roughly here. So axis of symmetry, that's the middle of our graph right there. Crossing the x-axis at 1 and 4. Got a y-intercept at 0, 4. I need one more point. May give me another point? What's that? 5, 4. So we're reflecting the 0, 4 across the axis of symmetry, and you get 5, 4. We'll fill in those points. Domain, all real numbers. God bless you. The range, Francia, what's the range going to be? Good. Increasing where, Andrew? Okay. How would I write that? Good. And then decreasing x is less than 5 over 2. We did it. We're a little quicker that time than the first time. But we went through those steps. Again, we went from standard to vertex and used the vertex form to help us find our zeros. How are we doing? Any questions? All right, so I want to hit one more with you, and that's number 21. But what's different about 21 is 21 has a negative 2 in front. And so I want to go back to the original notes and talk about what to do if you have something other than 1 for A. So I'm going to switch back to our notes. So if A is not equal to 1, here's what we're going to do. So let's say we have y equals 3x squared plus 18x plus 1. And I wanted to change that out of standard form into vertex form. We need it, so we first focus on this part here, the parts with the x, the 3x squared and the 18x. But don't start thinking about what would that perfect square be yet until you get rid of. You have to make a 1 before you can do that. So that's your first step. And so in this piece, I'm going to factor out a 3 just from the first two terms. I get 3 times x squared plus 6x, leave a little room, plus 1. So these are still equivalent. If I distributed the 3 through, I'd still end up back at 3x squared plus 18x plus 1. I'm just setting it up for what I want to do. So the 3's out in front, and that's going to end up being our a in front of our parentheses. So 3's a, and it already is a here. And now we need to complete the square inside. So scratch work, I'm thinking, well, maybe you've done it a few times. You know what the magic number is that I need to add? 9 is correct. Because we have x squared plus 6x plus something, and we want to create, you take half of 6, so we want to create x plus 3 squared. So then we're going to have 3 times 3 here, which is a 9. So 9 is what we want. So I add 9, but there's an issue. When I add 9, now it's not equal to the original. So I have to subtract something to keep it balanced. So what do I subtract? 9. Can I put it here? Is that balanced? If I multiply all this out, will I end up back where I started? No. Why not? Because when I this 9 inside the parentheses, when I multiply that by 3, because everything in here gets multiplied by 3, I get a positive 27, but then I have a minus 9 out here, and that's not going to zero out. You see an issue there? What if I put the minus 9 inside the parentheses? Is that fine? If I work through that, will that end up being equal to the original? Yeah, I will. But I don't want it there because I want to factor what's in the parentheses. I don't want that there. So how can we resolve this issue? So keep the plus sign inside and do what on the outside? So I'm going to put minus 27 or minus 3 times 9. All right. So the 9 inside has a value of 3 times 9 because it's in parentheses and there's a 3 in front. So I need to counterbalance that with a negative 3 times 9 on the outside. So that's something that is a little new, and you got to think through that a little bit. Once you're there, though, everything else is easy. So pretty much done because this is going to be 3. We know the part in parentheses factors to x plus 3 squared. And then 1 minus 3 times 9. Well, 3 times 9 is negative 27, plus 1 is negative 26. And now we've gone from standard form to vertex form. Let's try that one more time. So let's start with y equals negative 4x squared Sorry, I'm just trying to make it a nice one for us. Plus 32x minus 3. Okay, what's the first step? Factor in negative 4 out of all 3 terms? Just the first 2. So just the first 2. Now notice, guys, I'm not factoring. If I were factoring, I would factor out a negative 4x, right? I'm not pulling out everything I want, everything I can get. So I'm not pulling out the GCF. I'm just pulling out A. Okay? So careful there. So I'm factoring out just the negative 4. I want to keep the x squared inside. What's the next term going to be? Negative 8x. Leave a little room, minus 3. Those are still equivalent. Nothing's changed. Then come up with your magic number. So x squared minus 8x, that's going to be x minus 4 squared, so I need to put a plus 16. Okay, so I went from here back, just thinking about what I need. So I need a 16. That wasn't there though in the first place, so I need to balance my equation by doing what? Minus 4 times 16 would not balance it out. Right? Because this is minus 4 times 16. I'm going to do another minus 4. I got to put a plus 4. Okay. Once you're there, then you're almost done. One more step. Negative 3 plus 64 is negative 60. Sorry, positive 61. And now I have my vertex form. Okay. Now that we've practiced that a couple times, let's go tackle this problem. So 21. Y-intercept. 0, 14. Okay. You could try factoring it. This one it's not going to work though. Okay. I'll just tell you. I'll save you the time. So this one's not going to factor. We're going to have to use this method getting into vertex form. You want to try it without me? Try it without me, and then we'll compare. So y equals negative 2 times x minus 2's quantity squared plus 22. How'd you do? Any questions on where things came from? You didn't get that? Plus 18. Well, you put 4 on the inside though. So that's negative 2 times 4, so you got to put a positive 2 times 4 out here. Okay, so you got to use what you're adding inside there. Okay. All right, so we have our vertex form, y equals negative 2 x minus 2 squared plus 22. Our vertex from that we can get at what? Positive 2, 22. Let's get our zeros. So we're going to take the negative 2 times x minus 2 squared plus 22, set that equal to 0, and solve. What would be the first step to solve on this one? Minus 22. And then divide by negative 2. So you have to clear out everything except the x minus 2 squared before you take the square root. And so just to make it easier and cleaner for you. So here we have x minus 2 squared equals 11. Then take your square root. I'm going to make a mistake here. See if you can catch my mistake. Don't forget the plus or minus, okay? And then add 2, and you get x is 2 plus or minus square root of 11. And just right here, whenever your zeros have square roots in them that you can't get rid of, that tells me there's no way I could have factored this over those integers, okay? So that's why it's not factorable. There's no factored form. And our zeros, we split them up. We got x is 2 plus root 11, and x is 2 minus root 11. So we got 2 minus root 11 comma 0, and 2 plus root 11 comma 0. Again, it'd be helpful to use a calculator to approximate where these values are when we graph them. I'm going to do that. So I get negative 1.3 and 5.3. Again, approximating to the nearest tenth. All right, so I'm going to graph now. I'm noticing I have some big values, like the vertex is going all the way up to 22. So I'm going to compensate for those. Maybe I'll count by 2s on my y-axis. And I'll go by 1s on my x-axis. So vertex is at 222. X-intercepts at negative 1.3. So that's between negative 1 and negative 2. There. And that's my 2 minus root 11, 0. And then 5.3, so 1, 2, 3, 4, 5, a little bit more than 5. That's my 2 plus root 11, 0. And I have a y-intercept at 0, 14. I counted by 2s. It'll be right there. Need one more point. What would that be? If we reflect our y-intercept across the axis of symmetry, or line of symmetry. 414. Something like this. Our line of symmetry is x equals 2, domain all real numbers. Range y is less than or equal to 22, increasing when x is greater than 2, decreasing when x is, I'm sorry, I have that wrong. Let me fix that. Increasing when x is less than 2, and decreasing when x is greater. And then fill in the points. And we got it.